Hi kids, welcome to Lucky Maths. Lesson number 2, your grade 11 book. Indices and Logarithms 1. Have a look. We call this a to the power b. We call this a as base and b as power exponent, so index. This is base. And we call that b power exponents or index. Plural of index is indices. Look at these laws of indices. Laws of indices. You have same base a to the power m into a to the power n. Same base. See, that is equal to a to the power m plus n. What you are going to do in here, you add the powers here. So this is our first law. Next, a to the power m divided by a to the power n, that is equal to a to the power m minus n. Here we subtract powers. Next you have a to the power m to the power n, power of power. So that is equal to a to the power mn. Here you multiply power m into n. Next a to the power minus m. So that is equal to 1 over a to the power positive m. This is reciprocal. So then any power 0, a to the power 0, any power 0 is equal to 1. Let's see how to apply these laws in your calculation. Look at example 1. You have 2 to the power 2 into 2 to the power 3. What you have to do? You write 2, then you have to add powers. 2 plus 3, which is equal to 2 to the power 5. That is our answer. Example 2, you have 5 to the power 3 into 5 to the power 2 divided by 5 to the power 3. So, in the numerator, you have 5 to the power 3 plus 2, same base. So, we have to add powers. Divided by 5 to the power 3. That is equal to 5 to the power 5. 5 divided by 5 to the power 3. Now what you have to do? You have division, same base. Then you subtract powers. 5 to the power 5 minus 3, which is equal to 5 to the power 2 is our answer. Example 3, powers of powers. You have 5 to the power 2, 5 to the power 2 of power 2. Then you multiply powers. 2 into 2. Then divided by 5 to the power 3. Then 5 to the power 4 divided by 5 to the power 3, which is equal to 5 to the power 1. 1 means 5. Okay. Next, we have minus power. 3 to the power minus 2. So, you want to make this positive power. How do you do that? You have to take the reciprocal. 1 over 3 to the power 2. So, what is that? 1 over 9 is your answer. Then, example 5. You have powers of powers here. So, 5 to the power, you want to multiply 2 into minus 2. Then you have 5. Then you have 3 to the power 0. Any power 0 becomes 1. Then 5 to the power minus 4. 2 into minus 2 makes minus 4 into 5 into 1. Then here same base you can add 5 to the power minus 4 plus 1. No need to write into 1 because you have the same answer. Now minus 4 plus 1 means 5 to the power minus 3. So this is negative. You can write it as positive. You have to take the reciprocal 1 over 5 to the power 3, which is equal to 1 over 125. Look at example 6. Here you have algebraic expressions. 3a to the power minus 2 into 4a squared b squared divided by 2ab. So here you have 3a to the power minus 2. You can write this one 3 to the power minus 2 into a to the power minus 2 into you have 4a squared b squared, and here you have 2ab. Now take 4 front, then you have 3 to the power minus 2 here. Then you have same base a to the power minus 2 and plus 2. You have b squared over 2ab. Here you can cancel this 2 and 4. You have 2 there. Next you can write 3 as a positive power, 3 to the power 2. And numerator you have a to the power 0 minus 2 plus 2 equals 0. Then into b squared divided by ab. So then you have 2, 3 squared is equal 9. You have a to the power 0, that is 1. And you have b squared divided by b. Then you can subtract powers and denominator you have a. What you have here now? What is your answer? 2 minus 1, 2b over 9a is your answer. Our next topic is 2.1, fractional indices of a power. We can write square root of 4 using the radical sign as square root of 4. This is radical sign. This is equal to 4 to the power half, which means square root is equal to half power. So square root is half as a fraction. And also we can write 2 into 2 into 2. That is equal to 2 to the power 3. So here you have 1, 1, 1. Same base, you add powers. 2 to the power 3, which is equal to 8. Or you can call this 2 cubed. Also, you can write cubic root of 8 is equal to 2. Or 8 to the power 1/3 is equal to 2. Which means we can write cubic root of 8 as 8 to the power 1/3. Therefore, we can write with the radical sign nth root of a is equal to a to the power 1 over n. So this is our next indices law. This one is Very important. This is our next law. Let's see now how do we apply this law to simplify expressions with powers. Example 1. Find the value of cubic root of 27. Example 1. This cubic root power you can write 27 to the power 1 third. Now 27 is 3 to the power 3 of 1 third. Now powers of powers, you can multiply powers. 3 into 1 third, 3 cancel, 3 is your answer. Example 2, square root of 25, you can write it as half to the power minus 2. So 25 is 5 squared and half you have minus 2 power. Next, powers of powers, you can multiply powers. 2 to cancel here. You have 5 to the power minus 2. So you want to take the reciprocal to make this power positive. 5 to the power 2. So 1 over 25 is your answer. Next, example 3. You have cubic root of 3/8. So first of all, you want to make this improper. 8 into 3, 24 and 3, 27 over 8 you have. So next, you can write this as power of 1 third. 27 you can write 3 to the power 3 and here 2 to the power 3. 1 third. Next, you have power 3, both numerator and denominator. So you can write it as 3 into 1 third. Powers of powers. Then your answer 3 cancel. 3 over 2, which is equal to 1.5 as a mixed number, is your answer. Example 2. Simplify and express the answer with positive exponents or indices. Example 1. You can write this as square root of x you have. You can write it as x to the power half and you have 3 there as a power. So then powers of powers, you can multiply half into 3. So x to the power 3 over 2 is your answer. Next, here you have cubic root a. This one you can write as a to the power 1 third and minus half. Then you can multiply powers. 1 third multiplied by negative half, which is equal to negative 1 over 6. You want to make this power as positive, so you have to take the reciprocal, a to the power 1 over 6. This is your answer. Example 3, you have here square root and minus 3 power. So 1 over x minus 3 square root, you can write as half power. So then 1 over x minus 3 into half. So 1 over x to the power minus 3 over 2. You want to make this power positive. So you have to write it as upside down, which is x to the power 3 over 2. as a positive power. This is your answer. Example 3. Find the value of 1. You have 27. You can write 3 to the power 3. And 64 you can write as 4 cubed. So 2 over 3 power. Then powers of powers. You can write 3 over 4. Both you have cubed. Then you have to multiply by 2 over 3. So 3 cancel. You have 3 over 4 squared, which is equal to 9 over 16 is your answer. Next, you have 16 over 81. 16 you can write as 2 to the power 4 and 81 3 to the power 4. You have minus 3 over 4 outside. So then 2 over 3 fourth power into minus 3 over 4. So 4 cancel. You have 2 over 3 minus 3 as a power. So you want to make this positive. If you write 3 over 2 cubed, this will be positive. Say that is equal to 3 cubed is 27 and 2 cubed is 8. That is equal to 3 over 8 as a mixed number. Look at this example. Seems little bit complex. We can do it. 125 over 64. 125 you can write as 5 cubed. 64 4 cubed minus 1/3 you have there. Then you have fifth power there. You can write it as 32 to the power 1/5 of 3. Then any power 0 becomes 1. Now 5 over 4 cubed into minus 1 over 3 into 32 you can write as 2 to the power 5 into 1 over 5 cubed. Now 3 cancel. You can write it as 5 over 4 to the power negative 1. Then here 5 into 1 over 5 becomes 2 to the power 3. So to turn this positive, you change it upside down. 4 over 5 into 2 to the power 3, that is 8. You have 32 over 5, which is equal to 6 to 5 as a mixed number is your answer. Example 4, simplify. You have cubic root there, so you can write 343 x to the power 3 over 2 full as a 1/3 power divided by x. Then 343, which is 7 cubed. So there you have 1/3 power outside into x to the power 3 over 2. Again you have 1/3. You have to multiply. Divided by x. Then if you multiply 3 by 1/3, you have 3 cancel. You have 7 there. Here. Then here 3 cancel. Again you have x to the power half divided by x. Now what you have to do? Same base division, you have to subtract half subtract 1. So which means x 7 x to the power minus half. So you have to write it as positive, that is 7 over x to the power half there. Or you can write 7 over square root x as your answer. Okay kids, now you can try exercise 2.1. Our next topic is 2.2, solving equations with indices. Suppose you have 2 to the power x equal 2 to the power 3. Then we can write x equal 3 because base is equal here. Therefore, indices equal. See, base is equal here. Therefore, indices equal. X equal 3. Base is equal. Therefore, indices equal. In the same way, if you have x to the power 5 equal 2 to the power 5, we can write x equal 2 because here indices equal, so base is equal. X equal 2. Here I write indices equal, therefore base equal. Okay. In general, we can write now for x is greater than 0, y is greater than 0, y is not equal to 1 and x is not equal to 1. If x is not equal to 0, x to the power m equal x to the power n, then m equal n. If m is not equal to 0 and x to the power m equal y to the power m, then x equal y. Base equal, here base equal, indices equal. Indices equal, base equal. Next we will see how to use this rule to solve the equations with indices. Example 1. Solve. First you have 4 to the power x equals 64. 4 to the power x, you can write 64 as 4 to the power 3. So here base equal, therefore x equal 3. Indices equal. Next, here you have x cubed equal 343. We can write 7 cubed. So here indices equal, base equal, x equal 7 is your answer. Next, see this one. Here you have 3, here 9 and 27. 9 and 27 you can write in terms of 3. Let's see. 3 into, you can write 9, 3 squared. You have 2x minus 1 there. Equal 27, you can write 3 cubed. You have minus 6 there. Then 3 into, you can simplify the bracket. You have 2 into 2, 4x minus 2 equal 3 to the power minus 3x. Now from indices laws, here you can simplify this one furthermore. Minus 2, here you have power 1, you can add 1 here, equal 3 to the power minus 3x. Next, 3, you have 4x minus 2x plus 1, you have minus 1 there, and 3 minus 3x. So here base is equal, indices equal. Then you can write 4x minus 1 equal minus 3x. So you can take minus 3x to left hand side. Then you have 4x plus 3x here. And I'll take minus 1 to other right hand side. Then it's become positive 1. Then 7x equal 1. Then x equal 1 over 7. You have to divide both sides by 7. Okay kids, now you can try exercise 2.2. Next topic is 2.3 laws of logarithms. You know, using logarithm laws, we can write log 2 16 into 32 is equal log 2 is base 16 plus log 2 32 and log 2 32 divided by 16 equal log 2 32 subtract log 2 16. In general, we can write log A is base here, mn, equal log A m plus log A n. Log A m over n equal log A m subtract log A n. These two laws are very important when you solving logarithm calculations. Now we are going to learn another law. Log A m r. M to the power r is equal r times log A m. A is base here. Suppose you have log 5 125 to the power 4. You can write this as log 5 125 into 125 into 125 into 125. So this one, by using our previous law, we can write this one log 5 125 plus log 5 125 plus log 5 125 plus log 5 125. Same term, you have 4 times, and you can write 4 log 5 125. In the same way, you can write log 10 to the power 5. How do you write this one? You can take power to front 5 log 10 10. So log 10 10, that is 1. That means 5 into 1, your answer is 5. This is another law. Log AA is equal to 1. Here log 10 10 is 1. Look at this one. Log 3 5 2. How do you write this one? You can take power to front 2 log 3, 5. Okay. In general, we can write now log a m to the power r. You can take r to front, then log a m. This is our next law of logarithm. This is very important. And this law is also valid for fractions. See, if you have log 2, 3 to the power half, you can write half log 2, 3. This is valid for fractions. Let's take another example. Log 5, 7, 2 over 3. Again a fraction. You can take fraction to front. 2 over 3 log 5, 7. Next we will see how to apply these laws which you have learned so far. Example 1. Evaluate AG 1000. Look at this example. Here you have LG. LG means log base is 10. Otherwise, you have to write the base. If you write log, you have write the base here. Here base is 4. Here base is 2. So then you can identify if you have LG, that is base 10. Okay, let's start now. This one, LG 1000, you can write 10 to the power 3. So this one you can write 3 AG 10. So this is actually 3 LG 10 10. So you know LG 10 10, LG 10, that is equal to 1. That means 3 times 1 equal to 3 is your answer. Next you have your base is 4. You can write this one log 4 64. You have cubic root there. That power you can write as 1/3. So you can take that power to front. 1 over 3 log 4 64. Again you can write 1 over 3 log 4 64 is 4 cubed. So you can again take that 3 to front, then into 3 log 4 4. So 3 3 cancel here. Log 4 4, you know that is 1 is your answer. Next example, you can write log 2 2 2. You can take front 2 2 as a power plus log 2 4 to the power 3 minus log 2 squared. Then what you have to do, by using logarithm laws, you can write log 2. Here you have 2 to the power 2 and you have addition, then multiply 4 cubed divided by, you have subtract there, minus sign, so then divided, then you have 8 squared. Next you have to write, then we can write this 4 in terms of 2 to the power 2 and 8 also 2 to the power 3 log 2, you have 2 to the power 2 into, here you can multiply 2 to the power 6 altogether and denominator you have 2 to the power 6. Then you can cancel this 2 to the power 6. Next you have log 2, 2. What you have to do now? You have to take 2 to front, 2 log 2, 2, which is equal to 2 into 1. You know log 2, 2 is 1. That is 2 is our answer. Example 2. Solve. Here again you have LG. LG means base is 10 there. We have to find x there. LGX. I take LG 8 to the power 2 plus LG 5 squared minus LG 4 3. Then I can write here I have 8 squared into, here you have addition, then subtract 5 squared. You have to divide 4 cubed there. Here you have LGX, then LG 8 times 8. You have 5 squared. This one you have 4, 4, 4. Let's simplify them. You have 2 there, then again 2 there, then this, and this cancel. You have LG 5 squared LG x equal LG 25. So both sides you have log 10 base. Therefore, x is equal to 25. That is our answer. Next, you have to find x here. So we can write log, we have base is b here, 3 squared plus log b 2 cubed minus log b 72 equal log b x to the power half. You can write by using our logarithm laws. Next, we can take log b and we can write 3 squared into 2 cubed. Then subtract sign, you have to divide 72. Then you have log b power half. So how do we simplify this one? Here we have 9 and 9 times 8, and again this is 8 and 8 cancel. Then you have log b 1 equal log b x to the power half. Then both sides you have log b, then you can write x half equal 1. That means square root of x. To find x, what you have to do here? You have to take the square both sides. Then x will be 1. That is our answer. Example 3. Verify log 575 minus log 53 equal log 540 minus log 58 plus 1. Here you have to prove left hand side is equal to right hand side. Let's see. Take left hand side. Left hand side. What you have here? Log 575 minus log 53. Log Base is your 5 here. We can write 75. So log 5, 75. Here you have minus. So you have to divide by 3. So you have 25. So you have log 5, 25. Again we can write log 5, 5 squared. 25 is 5 squared. So by our logarithm third law, I take 2 front, then 2 log 5, 5, which is equal to 2. Log 5, 5 is 1. Next we take right hand side. Let's see what we have there. Log 5, you have there log 5, 40. You have subtract, then divided by 8 plus 1. Then 40 divided by 8, you have 5. So log 5, 5 plus 1 equal 1 plus 1. Log 5, 5 is 1. 1 add 1, 2. So what you have to say? Here, left hand side is equal to right hand side. Okay kids, now you can try exercise 2.3 and all logarithm questions in your review exercise. Thank you for watching.